welcome back to another episode of the Open Source Cafe, and I'm really excited to have Sakshyam again on the show. And we've had some great conversations in the past around Kubernetes, and today is one of such days. But before we get started with the main agenda, Sakshyam, would you like to tell our viewers a little bit more about yourself?
Yeah, sure. Thanks, Kunal. Hi, everyone. I am Sakshyam Shah. I'm based out in Nepal. I work as a developer relations engineer at Teleport. For those of you who don't know, Teleport is the most easiest and secure way to access infrastructure resources such as SSH servers, Windows servers, databases, Kubernetes clusters, web application across all environments, including cloud, cloud native, on-premise data center, you name it. So today I'll be giving a brief best practices around access control to Kubernetes control plane API server. So at the end, hope you'll learn few stuff that would allow you to implement a better access control in your Kubernetes infrastructure.
And if you want to learn more about Teleport, you can check out the links in the description below. I've done some tutorials on it on my channel. So hopefully that would be helpful to you. And the Teleport blog is actually also pretty active. They post some great content regularly. So make sure you check that out as well. All the links can be found in the description below. And yeah, I mean, like Sakshyam mentioned, we're talking about how to secure API access to Kubernetes control plane. So it's an introductory topic for folks who are aspiring to be Kubernetes security administrators. And we've already done a podcast together on cloud native security, like how to get started and things like that. So hopefully this would be an interesting topic for you all. We'll leave some resources for you to explore as well in the description that you can check out after the session. And yeah, let's get started.
So let's begin the topic: secure API access to Kubernetes control plane. The primary agenda is to make you understand about the security importance of Kubernetes API server. So why I'm starting to this talk on Kubernetes API server itself. Kubernetes, it's big. There are lots of stuff. Why API server? I'll elaborate on that part. And the remaining one will be to explain a few best practices, knowing risky default features that Kubernetes offer, so that you can avoid them and implement best practices overall related to API server access. So to begin, you have to first understand the Kubernetes components. Kubernetes, it's not a single product per se. So Kubernetes has lots of moving internal parts, and there are lots of resources that work in tandem, and every resources are abstracted in the beautiful API. And those are overall constructed as a Kubernetes control plane. And at the center of the control plane, you have this API server. So everything that Kubernetes has to offer can be operated by using the API server. So basically, it's like a brain of Kubernetes clusters. I don't know about Kunal, if you remember, but here in Nepal, when we used to be in early days of learning computer science, we used to get reference that the CPU of CPU is the brain of computers.
We do that too.
Yeah, yeah. So if you take that same analogy, so in Kubernetes, control plane is the brain of Kubernetes cluster. And the API server, it's also innermost core part of the control plane and innermost part of the brain of the Kubernetes cluster. So it's really, really important thing that you have to think about Kubernetes security. So that's the main importance of the API server. The access control in Kubernetes has built-in steps, or if you can say it, phases of access control. The first one starts with authentication. The second one is authorization. And the third one is admission control. And all of this, again, you also have to think about how the users connect to the Kubernetes cluster itself before they even authenticate. So you also have to think about the connectivity. And these are the stuff that you have to think about access control overall. Starting with how you can implement best practices is, first thing is you have to think about how you harden security of direct network access to the API server itself. right? Because the
Before we move
connectivity.
on to before we move on to
Mhm,
that,
mhm.
maybe we can also refer to the previous webinar we did, because it's sort of like when we talk about security. I know you mentioned in the previous one the four C's of cloud native, right? And
Yeah,
it follows like a four-layer approach when it comes to securing the sources. And can you maybe share a little bit more about where Kubernetes lies in that?
correct.
As you mentioned, it's like
Yeah,
not.
actually, I put
Yeah.
that towards the end of it, but again, I can
Ah,
bring that up as well.
that's okay. I just remembered it, so I
Talking
said it.
about Kubernetes security, yeah, it's incomplete if we don't talk about the four C's of cloud native, right? So Kubernetes itself sits in a one layer. And when you speak about security, you have to think about security of the data center that Kubernetes itself is hosted on. And you have to think about the containers and code that runs on top of Kubernetes. And so the connectivity part is really important, is because no matter how much you control access on the application layer, if the underlying host connectivity network resources are not well protected, then you will be exposing Kubernetes API server to any malicious intent over the public networks. So you have to think it that way as well. And again, let's keep in mind the four C's of cloud native security always, and you have to think about it in every phases of the access control as well. So let me just go back to Harden network access to API server. The first one you have to think about is obviously the basic one, which is network segmentation and firewalling. You have to get this thing right, because this is a basic and covers almost 90% security of your Kubernetes infrastructure. Actually, the same thing also applies to any network resources that you host in infrastructure. If you get the network segmentation and firewalling right, it just levels up the security overall. And the things before I move more forward, I want to mention is that uh, people rarely host the Kubernetes cluster from scratch these days. They use abstracted managed deployments, and the things I'm going to talk about should be applying in those all scenarios. Maybe some of the features are already implemented by the managed service provider by default, but knowing these constraints would help you understand the features better as well. So the next thing is related to network is use TLS everywhere and harden global TLS configurations. So you have to use and enforce TLS best practices for network traffic that connects the Kubernetes API server with kubelets, that connects the API server with etcd, that connects the API server with custom Kubernetes clients. And you have to choose strong cipher suites and enforce minimum TLS version so that the TLS connectivity stays secure at most. The third one, best practices for network access control, is you should be implementing a kubectl proxy. So the way we access Kubernetes cluster is mostly using kubectl, and kubectl under the hood just calls the Kubernetes API. And to access and authenticate, we usually use a kubeconfig file. So when the other person in our team, in your organization, wants to access same Kubernetes cluster, you might well be sharing. That's the insecure practice, but that's one of the way you can grant access to other users at other users at default state, right? So using kubectl proxy lets you host kubectl in let's say a secured security hardened bastion host, and just let other users authenticate to that bastion host and then access Kubernetes cluster. This can be configured by using a plain old as such bastion host, or maybe even using some dedicated solutions like Teleport. But you have to implement this. And kubectl proxy, it's a feature supported by kubectl itself. It's available by default. You should implement it. The last one in network access control is that Kubernetes API server also has this built-in proxy feature, which lets you access internal resources hosted inside Kubernetes. For example, if you have deployed Elasticsearch in your Kubernetes cluster, mostly it will be in a private network by default, and you won't be able to reach it outside the Kubernetes cluster network. But with the built-in API proxy feature, actually it lets you access the internal resources. This can be like beneficial, but also can be risky because you might be just exposing internal service to outside users out there. So you might want to disable it or maybe control who can access internal resources via this API. You can just blacklist to some network access at minimum to block this. The next one for the best practices I want to talk about is managing user accounts in Kubernetes. Kubernetes has this notion of two types of user accounts. The first one being normal user account, and the second one is service account. So normal user accounts are used by people like us who manage Kubernetes cluster, uh, and we usually use kubectl to utilize these normal user accounts. The best practices you can follow here is to unify and consolidate the corporate identity and Kubernetes identity. So these days, most organizations use already be using directory services like Okta, Google Workspace, Active Directory. So it makes sense to consolidate identity that we use in other services and the user accounts and identities in the Kubernetes as well. So it just makes it easier to administer the user accounts across all resources in a company. So that's the first best practice you can do. The second one is moving forward to service account. This is the most interesting part and riskiest part because everything that happens inside Kubernetes cluster will be attached to a service account. So it's mostly used for machine to machine access, and everything that has the Kubernetes API that's not using by us normal user accounts will be attached to service accounts, and they will usually be attached with sensitive privileges and roles. We'll be talking about roles and privilege later on, but that's what service accounts you should think about. And the first one, best practices for using service account is avoid using default accounts. You'll get a service account by default when you spin up a Kubernetes cluster, and you should avoid using default one and create a new service account that will be of least privilege and will be only used to perform a certain task that you require to communicate with the API server.
This is to like reduce the complexity, right? Because it can get complex when we're working with IAM solutions or something.
Yeah, yeah,
So if
yeah,
if it's like you're working with like more than one applications that use
correct.
same privileges, so can
Hmm.
we reuse like the existing accounts rather than creating a new one?
For that, yes, of course. If the requirement for the privilege and roles and resources they will be accessing would be similar, in that case, it's obviously a best practice one to reuse the service account. Just don't use the default ones, but create a new service account with minimum privileges and share that across all accounts. So that again, it comes down to one account. It will be easier to track the sensitivity of service account. Where does it hit? Across all API endpoints. So in that case, yes. The tip which I want to share here is that you can actually delete a secret credential associated with service account. This one comes in really handy when you don't want to delete the whole service account itself, but disable it for some time so that you can block access. So I personally use it frequently during test phases and stuff. So, but overall, this command can be very handy. Service account continued. You should disable service account for pods that don't need to communicate with the API server. So not all the pods you create needs to communicate with the API server, and if it doesn't, it doesn't make sense to assign it with the service account. But when you create a pod, and if the flag auto mount service account token is true, it creates the service account is created by default. So if it doesn't need to communicate with API server, you can just not create it by assigning a false flag. So it will not be assigned with any service account. This other one is use different signing keys to sign and verify service account. So Kubernetes by default, when you configure TLS connectivity, Kubernetes will use that TLS key pair to sign certificates for service account. And since TLS connectivity and key pair will be used mostly for TLS, it doesn't make sense to use the same certificates to sign service account as well, because you'll just first thing is you're just reusing the certificates for other purposes, which it's not meant to be. The other thing is that if you want to rotate certificates for TLS, then again you have to rotate and re-sign the service accounts as well, and which might cause a downtime. So the first thing you can do here is generate a different sets of key pair that will be specifically used to sign service account. And the way you can do is pass this flag service account key file and service account private key file when you start a Kube API server, and Kubernetes will use the certificates to sign service accounts. Next, moving towards authentication best practices. The first one here is disabling anonymous access. I personally don't know why Kubernetes actually implemented this feature, because anonymous access has been like wreaking security incidents from way back in the infrastructure security space.
Kubernetes in itself, it's not secure, right? Maybe one of the
Yes.
advantages.
And the point is that why would you even offer such features? I think it helps during maybe development environments and such, but I know why would it offer the security incident part. And let's say, for example, FTP servers, MySQL databases, they're all riddled with the vulnerabilities related with anonymous access. So you have to disable it. In most cases, it should be disabled and managed Kubernetes services, but you should think about it. The second recommendation I can give here is bring your own auth. Just like you should consolidate identities across your organization and Kubernetes cluster. You should also consolidate authentication. You can do it with using single sign-on, so that authentication process is deferred to whatever is already implemented in your organization, right? So it becomes a center part to manage policies related to authentications and such. Kubernetes supports various types of authentication, including certificates based on X509, bearer tokens, static tokens, bootstrap tokens, OpenID Connect tokens. And you can use OpenID Connect token to implement a single sign-on. The other thing I want to mention here is avoid authentication via static tokens. Static tokens can be helpful during development environment, or maybe in internal CI/CD pipeline where you just want to authenticate with a same credential, so that it doesn't create much overhead. But the security risks associated with is much bigger, because it's just a basic file that you need to supply, and the file itself can be compromised. The other thing is that it lives on, and you can't update or reset the static token unless you restart the whole Kube API server itself. So it might again cause a downtime. So it's basically recommended not to use the static tokens. The third one, best practices, is configure only one authentication method for users. So as I mentioned earlier, Kubernetes support many authentication method, but if you configure two or more different authentication method for a single user, so how the malicious user might exploit is just make the system fall back to the most insecure authentication method and use it to bypass the security controls you've implemented. So at minimum, always make sure that only one authentication method for a user is defined. There's a case where you might also, in terms of preventing downtime, you might want to add a backup authentication method. But I think one or two for a few account would suffice, and not for all the users.
That's
And the
because
last
like when you have when you have like multiple methods set up, so
Mhm.
when you get authenticated by one, Kubernetes will
Mhm.
not really check for all the other ones, and it will forward the requests.
Yeah, Yeah, but how one might how one might exploit is just make the secure authentication method not work in the Kubernetes system itself. That's a possibility of way of introducing chaos, right? So if one doesn't work, and you may trick the system to fall back in the insecure one. So that's one primary reason. And finally, decommission unused auth methods and tokens. Again, it's similar to configuring single authentication method. Is if you configured authentication method in the past that's no longer being used, I think it's best to revise those and just decommission it so that it doesn't create problem in the future. Now, moving towards authorization best practices. This is the most trickiest part overall because authorization is basically not even in Kubernetes in every systems out there. You have to carefully use the roles and privileges given by the system, which can be easily misutilized by users, malicious users. So, first thing, again, you have to carefully and rigorously understand what are the roles and privileges associated with the roles that you have available in your hand. And because once you know them, then only you can understand how to carefully use them. So Kubernetes has basically two types of role, one being role, which is confined within a namespace. The other one is cluster role, which which can be applied to overall cluster in Kubernetes across various namespaces. You can assign roles using role binding. You can assign cluster roles using cluster role bindings. And there are four major built-in roles. First one is cluster admin. So this is basically like root user in Linux, root or super user Linux, or administrator user in the Windows systems. In Kubernetes, it's called system masters as well. So this privilege just gives you access to everything, and you have to carefully think about who has access to this role. The second one is admin role. This admin role has read write access to a resources, but within a namespace only. It can create and alter roles and role bindings as well, meaning it can create a role and assign that role to other users as well. The third one is edit role. Edit role, again, it has also read and write access to resources in the namespace, but it cannot create and alter roles and assign roles to other users. But what it can do is it has access to service account, which can be used to escalate privileges. So careful consideration must be taken on what this user you assign with edit role can do with service account. Kubernetes offer different verbs which you can use that if a certain user with certain role may not execute certain features under, even if they are assigned access with those stuffs. And the last one in the built-in role is view. With view, it's a least minimum privilege, read-only access to resources within namespace, cannot view resources like secrets, roles, or role binding. So following these principles of least privilege, the view is the best one to start with, and you can obviously fuse this role with other verbs to create a final privilege that only just works for the things that are required to be done. Once you know about the built-in roles and privilege, is obviously following best practices on implementing role-based access control. Kubernetes also supports attribute-based access control, but the RBAC is the most recommended one and works very well. It should be enabled by default in most cases, but if it's not, you can enable passing the flag authorization mode equals to RBAC. And it's in the RBAC we should follow the principles of least privilege. Moving forward, you also I'm introducing you a few of the risky features or verbs that are available in Kubernetes that you should carefully use and assign to other users. The first one being the bind verb. It allows users to bind to other roles they don't have access to. It's basically a way to escalate privilege. And then you have the other verb that its name itself is escalate verb, which allows users to escalate privilege. You should be careful about who you assign with the escalate verb. The other one is impersonate verb. It allows users to gain right of other users impersonating. The other one is workload creation privilege. If any user has this privilege, they can access the underlying Kubernetes nodes and just pivot out from the Kubernetes cluster and access the resources in your infrastructure, underlying operating system server. The other risky one is listing secrets. You have to be very careful who is allowed to list and view secrets. If any users with this privilege can just log into authenticate with the Kube API server and view secrets associated with service accounts and such. So should be very careful who has access to listing secrets. The other one, similar to workload creation privilege, is persistent volume creation privilege. It just allows to create a new persistent volume, which can be pivoted and misused to access underlying host. And finally, the other one I would mention here is related to token request. This is also very funny one because it allows users to create new tokens for existing service account. It's just like basically resetting a password of service account and choosing a password of your own choice, and you can of course misuse that. You can reset the password of other service account. So you have to be very wary of these risky features. There are others as well, but these are the ones you should definitely think about when managing authorization. The other one is scope service account role to application specific roles. So when you create service account by default, it will be confined to the default namespace which it is being created on. And as we discussed earlier, is you might be willing to share the service account with other application under other namespaces. So when you do that, just be careful that you are assigning sharing the service account. You are scoping it to the only application or namespace that you want to share with, at not to the overall cluster in the Kubernetes environment. So you have to think about that when you share the service account with any other resources. Just make it very specific. The other authorization best practices everyone must know about is the flags authorization mode equals to always allow, and the other one is insecure port. So when you pass this flag authorization mode equals to always allow, Kubernetes actually will allow to access API server without any authentication and will allows no matter what. So it's very risky. The other more funny and security riskiest one is the insecure port. When you supply this flag, Kubernetes actually just ignores authentication, authorization, administration control overall, and just lets you access the Kubernetes API server. So never, ever, ever use this in production, not even in development environment. Using static tokens is much better in this scenario, even if you want to use, but never use insecure port and authorization mode always allow. Finally, admission controller. So admission controller is one of the things I personally liked when I first heard about Kubernetes access control. It's basically once a resource who wants to access an API is authenticated and authorization, it doesn't mean that the entity who initiated the API request is genuine. And admission control just lets you check in the last phase and verify that even though the request is authenticated and authorized, but isn't going to act maliciously on your Kubernetes cluster. So there are many admission controller available and offered by Kubernetes, and you can build one yourself. It lets you enforce security minimum standards. For example, the node restriction admission controller allows to give you access to the request made by kubelets. The pod security policy admission control lets you view the request that's everything related with pod creation or modification events. You can even apply container image scanning and stuff like that in admission controller. Admission controller also supports webhook, and this is also interesting because it allows you to initiate a request to external security engines you may have in your organization, validate it the API request against the external security resources, and make the final decision if the API request should be allowed or not. The one thing here is obviously think about proper timeouts to reduce latency, because when using webhooks, it just creates uh, requests to other external resources, mean that it is subjected to a network latency and stuff. So if it's not handled properly, you might just create latency overall in the API cluster, which means that since it is used by everything in the Kubernetes cluster, it might affect other operations as well. Uh, that's mostly with the access control. Some few steps you definitely should understand, which might be applied to beyond access control, as well as logging the API events. What you should log everything that touches the API server, including authentication, authorization, admission control, you name it. So everything should be logged. You should also think about securing access to Kubernetes dashboard. There are many security incidents that exploited unprotected Kubernetes dashboard, so you should think about that. And also use the tools that is offered at a minimum. And when we speak about that, using tools at a minimum that is offered by default, segregation based on namespace is the best thing you can do in Kubernetes. Just isolate the workloads so that even a vulnerability in one resources may not be pivoted, exploit the API server and pivot it into other workloads. So that's one thing you should apply. And you should always pull and use kubeconfig files from trusted sources. You can't. Many people during when they start learning Kubernetes, they just copy paste kubeconfig codes from Stack Overflow or blog posts. That's risky. Even if you do that, you must know what you are pulling and copy pasting in kubeconfig files, because that's the easiest way one can trick you to compromise the Kubernetes cluster. And lastly, you should also think about limit ranges and applying resource quotas. That's offered by Kubernetes to prevent DOS attacks in API. So in API operation, when you integrate access control with external authentication system, enforce many authorization check, have implemented admission controls that communicates with external resources. These can be exploited and flooded with requests that just will waste the underlying computing resources in your Kubernetes cluster. To prevent that, you can use limit ranges and resource quotas, which will help you to avoid DOS attacks, simple DOS attacks. And lastly, again, don't ever forget about the 4Cs of the cloud native. Everything depends on the overall security of cloud native. No matter how secure the API server is, again, if the underlying or the resources that are hosted on the Kubernetes itself aren't secure, everything can be exploited, pivoted, and further pivoted to compromise the overall Kubernetes ecosystem in the cluster which you host in your infrastructure. So that's it overall. Hope it was insightful and I was able to give a few best practices related to API access control.
Amazing. Well, thanks a lot for sharing, Sakshyam. A lot of great tips and things to take into consideration. But yeah, I mean, that was it. And for folks who want to learn more about it, right, as you mentioned at the beginning of the session, can you point them to some resources?
So I think Kubernetes has done a well job on well documenting everything. The problem is that just because Kubernetes had lots of features itself, so the documentation, it's hard to find and try to find the thing that are required most. But I think most of these stuffs are included in the Kubernetes documentation, and I would recommend everyone to start reading those. I've just pulled lots of stuff from the documentation and collected it so it's easier to understand. But everything is available in the docs, and that's the one place I definitely recommend everyone to check out.
Amazing. Well, thanks a lot for sharing, and I'll leave all the links in the description below. As always, a pleasure to talking to you, Saksham. Really appreciate you giving the time. And thanks everyone else for watching as well. Do check out Teleport, check out the videos we've done, and documentation and blogs and everything can be found in the description below. And we'll see you in the next one. Have a great day. Bye.
Okay, thank you, Kunal.